So we have 2 sections to do today. These are the last 2 sections, and then you have tests on Friday after we review on Wednesday. No, that's a lie. Quiz Wednesday, review Friday, test Monday. Okay, so we're doing inverse of relations and inverse functions. So you should know the difference between a function and a relation. Graphically, a function has to pass the vertical line test. By definition, in order for it to be a function, when you put in an x, you should only get one y. You shouldn't be able to have one input going to and giving you 2 different outputs. Okay, that's what makes it pass the vertical line test. A relation will be given to you like a set of ordered pairs, or like a little table, or like a mapping, which like the mapping is like the little things like this, and then go like this. That's a mapping. Okay, or it will just be like this, a list of ordered pairs. Okay, that's usually what relations look like, or it could just be a graph of a bunch of dots. Okay, that's what relations present themselves as. So if you want to find the inverse of a relation, all you do is just switch the domain and the range. So you take all the x's and they become y's. Then you take all the y's and they become x's. So if you look at this table and you look at this table, that's what you'll see. 0 was the x, now it's the y. -1 was the y, now it's the x. All the x's switched with all of the y's. And so the domain becomes the range, and the range becomes the domain. And that's what the definition of the inverse of a relation is. Okay, so it's when you have the domain and the range swapped. Okay. Now, that's easy to do when you have a finite number of points, but if you have an equation, you can't switch every point because there's an infinite number of points in a function, like y equals x. That's a line. There's an infinite number of points on there. We can't switch all of them. That would be crazy. It'd take us forever. So we have some steps. Now, if you printed the notes out like a while back, like via the PDF, your picture is going to look different than mine. I don't know what happened. I just like opened up the file and it said that like the picture was gone. So I had to like find a new picture. So this is just it's the same idea. I just have a different picture than the notes do. So if you look at this dotted black line, that is the line y equals x. I don't know if you can read that. It's kind of small.
Do you want us to draw this out?
It's up to you.
Yeah, I'm not
Okay, so the line y equals x is like a super basic line. It has a slope of 1 and has a y-intercept of 0. It's like the most basic of lines, so it's like the parent function for lines. If you take a function, let's say this blue guy, and you were to reflect every single point across this line, okay, so like, you see, if you take every point on the blue line, and you reflect it across the line y equals x, what you're doing is you're saying that all the x's are going to be y and all the y's are going to become x. Hence the reflection across the line y equals x. You're making y x and you're making x y. Then you get this line over here. And it works vice versa. So if you, this actually is technically, it says like, it calls this guy f of x, and it says f to the -1 power of x. This is the notation for the inverse function. So when you see function notation and then a little superscript with a -1 power, it's not really a power, that just means the inverse of a function. So if the blue one has the -1 and the red/pink one does not, that means that this guy is the original. If we take every single point on this line and we reflect it across this line, we get the blue line, and that would be its inverse. Okay, so the inverse of a function is its reflection across the line y equals x. It's where all the x's become y's and the y's become x's. So you're just doing a switcheroo. The domain becomes the range becomes the domain. This is another example. Got a little swooshy thing here. If we take every single point here, so for example, the point 3, 0, if we make the x a y, or as point, what did I point to?
You're pointing to the Y.
really
That's what I thought, yeah.
I don't know
So if you make the y the x and the x the y, then you are finding the inverse of that particular point. And what you're also doing is reflecting it across the line y equals x. So if you look, 0 was the y, it's now the x. 3 was the x, it's now the y. It is the reflection of this point across this line. And if we were to keep doing that, so I don't know, let's take maybe this point. I think this point is maybe at like 4, 1-ish. If you take this point and you flip it so that the x becomes the y and the y becomes the x, then you get, right? See, it's the reflection across the line y equals x, and you get 1, 4. And if you were to keep doing that, you'd get this guy, who is the inverse of that guy. He's blue. I can do it.
So just look at the two x and y's and then just draw another.
Right, now, but we can't do that for functions, because how many points are on this curve?
All of them.
Yeah, like too many. So we're not gonna just flip a bunch of points. That's gonna not make any sense. Okay, so what we're gonna do is these steps. So there are steps to finding the inverse of a function. Okay, your first step is, if it's in function notation, we're just gonna take it out of function notation temporarily. So if it's like f of x equals, you're just gonna take that and turn it into a y. Okay, so you're taking it out of function notation temporarily. Okay, the next thing you're gonna do is switch the x and the y. So wherever x is, you're gonna put y. Wherever y is, you're gonna put x. So you're switching them. Then you're gonna solve the equation for y. So what that means is you're gonna get y by itself. Okay? And then at the end, you'll use the inverse notation to show that whatever you just found is the inverse of the original function.
Are we gonna have our before the exam? Are we gonna like go over every equation that we need to know or no?
I mean, there's a review sheet. If that's what you mean. Yeah.
So for like example 1, which one is like the red line is the original one?
Oh,
And
you
then
mean
the
here.
blue one. Yeah.
I mean, it doesn't matter. Like, it works both ways. So yeah, if you're looking at red as the original, then the
Yeah.
inverse is blue. If you're
The
looking
inverse
at
is the
blue
one
as
that
the
has the
original, the
negative one,
inverse is
right?
red. Yeah, technically, like the
Okay.
one with the -1 power is like the inverse that we would have found. But they work like both ways.
Yeah, it's like the same.
Like lines are especially. All right, so I have this lovely square root function, which we'll graph a little bit later today. It is in function notation, and we want to find the inverse. Okay, so just real quick, that this function kind of looks like it's got a horizontal shift to the right too, and it kind of looks like this. It looks like half a parabola, like on its side. So what we're doing is we want to reflect it across the line y equals x. Okay, but we have to do that for all points, so everything in the domain and everything in the range. Right now, if we were to find the domain of this, we kind of did that yesterday. So the domain of f of x, okay? What x value, if we plug in, would be our boundary for where if anything was smaller than that, we'd be square rooting negative numbers.
3, 0. No,
0
that's just-
minus 2 is -2, so that's
yeah,
negative.
So 3
Two.
minus 2 is 1.
Okay, well that's 1. What about like 0.9?
Oh, true.
Okay, so 2 minus 2 is 0. Can we square root 0?
Oh, it's just
Yeah.
0.
Yes. Okay, so 2 would be this absolute smallest number we could plug in.
Okay.
Otherwise, if we plug anything smaller than 2, like 1.9, we're gonna get like -0.1 or something. Like then we square root that, and you can't do that. We get imaginary numbers. So 2 would be our smallest number, and then anything bigger than 2, like 3, would work as well. So right now, if we were to think about the domain of that, that would be x has to be greater than or equal to 2.
If you want us to like write up every time.
We might as well just practice it. Now, so at the end of this, when we find the inverse, we're gonna wind up switching the domain and the range. Now, we didn't really talk about the range, and we're not going to until like the next part of this when we graph it, so I'm not gonna go into the range at the moment. But basically, when we plug in 2, that kind of gives you like the beginning of your range, and then values will increase or decrease from there. So if we were to plug in 2, what would we get total, like after simplifying the whole thing? So 2 minus 2 is,
0.
square root of 0
So it's
is,
0.
okay, so 0 would be the start of your range, and then it would either increase or decrease after
Yeah.
that. If it's positive, it increases. So without going into too much detail, the range of our function is gonna be that y has to get bigger than 0. Because it's not gonna get smaller. All right, now let's find the inverse. So the very first step says change f of x to y. This is if necessary, it might not be. So we have an f of x here, we're gonna change that to y. All we're doing here is just taking it out of function notation so that we can perform the rest of the steps. It just makes it easier. Check. Now we're going to switch x and y. You're literally just like swapping their places. You're not doing math. You're just turning the y into an x and the x into a y. Okay, so no math there. Just do that. Okay, now here's where the math comes in. So now your objective is to solve for y. So you need to get y by itself. Okay, so right now, there's a 3 here that's in the way. We need to get rid of first in order to get y by itself. So how can I get rid of that first?
Divide by 3.
So divide by 3. So that would give me x over 3. If you want, you could also write that as like 1/3 x.
Nah.
You might need to in certain
Square root
situations.
So like, when you square x over 3, like what?
Oh,
like,
no,
what do you
square.
get?
What does it mean to square something?
Did 2, that multiply
Oh.
itself. So x squared over 9, is that just it? Okay. I don't know
Okay, so
I
why
was
are you
thinking
squaring it?
to get rid of the square root.
So you're trying to isolate y, we need to get rid of the square root sign. So you're gonna square both sides. That's gonna give you x squared over 9.
Plus 2.
Okay, that's, again, you could write 1/9 x squared. And then you would add the 2. So that's x squared over 9 plus 2 equals y. Again, or 1/9 x squared plus 2.
Can I?
So we solved for y, aka get y by itself.
Can I put the x to the 2 plus 2 all over 9 or only?
No, the 2 was not divided by 9, the 2 happened after the 9 happened. Now the last step is to rewrite the equation in function notation. So you're gonna rewrite it so that you have, instead of y, the inverse of the function. So if the function is called f, we want the inverse of f, and that is gonna be equal to x squared over 9 plus 2. Okay, or what I was trying to say before is you could also write this as 1/9 x squared plus 2.
Is there a
which
way you
the same
prefer?
thing. I mean, this is like standard form, if that care, if you
Wait,
want
which
it.
one did you just point at? Sorry. I just-
The second one is like
Okay.
standard form of a parabola. Do you even know it's a parabola when you look at it like this?
No.
Then you should write it like that. Okay, this is standard form of a parabola. A is 1/9, vertical translation is up to, and there's no horizontal translation, so it looks something like this.
So we graph like the final answer, right?
I'm graphing it so you have a visual, you don't really have to graph it, but I'm also graphing it because your exam is coming up and you need to know all these things.
Yeah.
So by the end of this week, you need to be able to look at this or this and know exactly how to graph it quickly, and it shouldn't take you 3 hours. You should be able to look at it and in 10 seconds, like I did, know what it looks like. Maybe not get points out of it, but at least get a starting point and know approximately what it looks like, and you'll be able to do the same with that too. And if you can't do that by the end of this week, you're not gonna do well in the midterm, okay? So we've done a lot of graphs. We need to make sure that we're going through and reviewing all those. So I'm doing it really quickly in class, but I want you to pay attention because this is me like subconsciously pushing information back into your head, okay? Now, if this is a parabola, we know that the domain is what? All real numbers. Now, that's not what we said would happen, right? So originally, we had the domain of our original, so that's a pinkish one, this guy. we said that when we found the inverse, they should switch. So the domain would become the range and the range would become the domain. Now, some of this happened, but some of it didn't. So the domain of the pink one, okay, should become the range of the blue one. So does the blue one have values greater than 2? Yes, so that worked, but when we went the other way, so in theory, the range of the pink one should have become the domain, and that didn't happen, and that's okay. And that's because when you get into square roots and squares, if we were to go the other way, so if we take this parabola, if we were to reflect it across here, going the other way, so taking the quadratic and finding the inverse, do you see how, like, we only have half of it, right?
Yeah.
So going the other way, we would have had like this, right? This is not a function because it doesn't pass the vertical line test. So in order for us to go from like the pink one to the blue one and it be a function, we have to sort of take away half of it, otherwise it's not a function. And so in this case, the range and the domain don't switch because this one is not allowed to keep going and still be a function. If we go through these steps with this as the original, then eventually we'll wind up like square rooting both sides, and when we do that, we'll have a plus or minus, and that will create that second piece. Now sometimes the inverse of a function is not also a function. So it would have worked if we had gone from blue to pink, we would have seen like the domain and the range switch completely, and we would have seen like this little U shape reflect perfectly. So we would have seen it, it's just that we wouldn't have created another function. So sometimes when you find the inverse of a function, you don't get another function. Sometimes you do. But when we get into squares and square roots, that's kind of when it doesn't go both, like it's not going to be the same both ways. You're not going to get the same kind of reflection. If you look at, like some will do ahead of this, like this thing, like this is not a square root. You can graph looks like, you can just graph it on your calculator. They're kind of weird. They look like two little swooshy things, and there's like these things called asymptotes that we haven't really talked about. So we're not going to graph these.
Briefly spoke about it.
Yeah, maybe. So we're not going to graph them, but we can still find the inverse of them. So what we're going to do is, and we can still talk about the domain. So see how there are x's in the denominator here?
Yes.
Okay, so the domain of this would be that x cannot equal whatever's going to make the denominator 0.
So it'd be -1.
No, 1.
Just
Oh,
regular
one.
one.
Just 1.
Yeah.
Just 1.
So x can't be 1, so that would be the domain. All right, now let's find the inverse. So first step for finding the inverse is to just get rid of function notation.
These people on the GoPro must think I'm stupid.
Nobody watches them.
I
I
watched
watched them.
Well, there you go. Then you already
I do
know that
actually,
Tristine's
yeah.
stupid. I'm just kidding.
Well, we're already in the class, so we already know, dude.
I know.
But like when you get confused about one part, you're like, oh yeah, I need to like have Miss Rep tell me this again. You're like, you gotta go.
Some of the
through
things that
that
Tristan says, though, really just confuse me more. I
The
tried.
thing is
Alright,
that,
wait,
like,
wait,
I don't
stop,
fail
wait.
the class.
Stop.
So, like,
What's
no
our
one
next
should.
You do
step?
better than me by like
Change
10
it.
points.
Switching.
So you're gonna switch.
I do
You're gonna
really bad.
invert so that y is now x and x is now y.
I got 96.
Yeah, like it's 76.
Ray, you move your head next
Now
to
this
me.
one's gonna be different to solve.
Oh.
So this might take you back a little bit to chapter 1.
Isn't it like the
Do you
fun
just
ways
multiply by the
So in order to solve for
No.
y is in the denominator.
Oh,
I
it's on
cannot
there.
get y by itself. Well, it is a denominator.
No.
I need to multiply both sides by y minus 1.
Not the 2, just the y minus 1.
Yes, the Y minus
Just
1.
leave the 2. That
Right.
2 is fine right now.
Ooh, wait,
Then
we're combining two letters.
What is going on?
I have to take the y out from
Oh.
the dungeon.
Oh,
And
so
then
then
we
you just
divide
divide by
by
s.
Sure.
The dungeon. That's very inquisitive.
So then it'd just be y
Y.
equals
Wait.
2 over x
You missed it.
plus 2.
Just need
Plus
just
1.
Calm down.
Wait. I wrote it wrong.
Okay, now there are other ways to write that maybe you wouldn't think to, but like if they had a common denominator. So
I'm confident here, but I can't.
It's when you write those little circles instead of multiplication signs that's when you get me.
Alright, look,
The little circles.
if we were to combine these with a common denominator, it would look like this. So just so you know,
In this column.
these two look really different, but they're actually the same.
Holy
You're
crud.
doing it wrong.
What were you doing?
You were like plugging it into one. You had to plug like it into one.
And
then
this
plug
is
it
our
into
inverse of f.
What do I do? Because I didn't do half of them.
Yeah.
I was proud.
There
I did-
is a
I'm
lot
serious,
to that I would have to teach in order to teach you how to graph it.
My
Yeah, I don't want to graph that.
That
on
one
the-
has what's called a vertical asymptote at 1 and then a horizontal asymptote at 0, and it looks something like this. Whereas this one has a this one has a vertical asymptote at 0 and a horizontal asymptote at 1 and
What is
looks
an
like
asymptote?
this.
The funny thing
Asymptote,
is, for
Basically
all
the asymptote.
for all we
switch.
know, she could be like talking complete like gibberish, and like
Oh
we
my
believe
God.
her. Like imagine like.
Yeah,
Oh no,
asymptote is
we'll
gibberish.
graph
No,
them.
like,
just not
I
Imagine, like,
believe
teachers
you.
are telling
I
us
believe
fake
you, but
information.
like
Asymptote?
if we don't know how to
Emma.
do something, you're like, yeah,
Sure.
what is this? That's like the one thing I actually said.
That was stupid, Tristany.
No worries.
Okay, now how do I get rid of a 2/3?
You multiply by 3 over 2.
Wait, it's 2/3? I just did this entire problem wrong.
So you're gonna multiply by the
Started.
reciprocal.
The thing is, like, you were like, my problem's really looking good.
So I have 3/2 times the quantity of x minus 1. Make sure you put that in parentheses.
Quantity? What do you
Quantity when it's in parentheses. Or you could distribute it, but I'm not gonna do that.
Hold on. I'm a little behind because my
Yeah,
problem
no,
was
hold
written down incorrectly.
Okay, so wait, we took. Oh my god.
We
then
multiplied by 3/2 to get rid of the 2/3.
So
And
then
that's it.
wouldn't
That's
you
all I
just
Under
square
three root all of
everything?
it?
Yeah, square root all of it.
You really emotional.
And I'm stretching perfectly.
Now, when you use the square root property,
Don't you like?
you have to put a plus or minus
Oh,
in front
no.
of the square root.
See, I never know when we're putting a plus or minus or not.
It's when you have the square root. of
But
something.
sometimes we don't.
Whenever you use the square root property, you put the plus or minus. So you have to know what that is in order to know when to put the plus or minus.
So we just leave it like that. That's the end of the
Sarah
problem.
just texted.
No, then you put the inverse of f
Yeah.
is plus or minus the
No, it's a
square
magic.
root of 3/2
Sorry, my
times
bad.
x minus 1. Alright, listen. Sometimes this number can simplify. This is not one of those times. But if that number was like 9/4, we would take it out of the radical like we did in section 1 and we would simplify it.
Okay.
So remember in section 1 when we simplified things. So side note, if it was something like this, you know that we can
So
separate
3/2.
these and get 3/2 root x minus 1, and that's what we would do.
Wait, what happened?
If this was
What
what we
that
had,
meant.
we know that we can separate those radicals and we can
It's
simplify
like 3/2 squared.
this one, and so we would take out the 3, we would take out the 2 out of the radical because those are perfect squares and they square root. The square root of 9 is 3 and the square root of 4 is 2. Now we don't have a square root of 3, we don't really have a square root of 2 that give us like rational numbers, so we can just leave them in there. There's no friend, they don't come out.
I have a question. Can we have a break today?